When Tesla announced that its new chip would be installed in robots first, not in cars, the market reacted with skepticism. Analysts raised questions, competitors ignored the news, and most media outlets treated it as yet another overhyped promise from Elon Musk. But there was one detail in this story that changed everything. This chip consumes just 250 watts of power and delivers performance equivalent to a $30,000 device. And this isn't just a promise. The design is already finalized. To understand what's happening, you need to start with a technical term that very few people outside the semiconductor industry know: tape-out. Tape-out is the moment when a chip's design is considered final and sent off to manufacturing facilities. It's the point of no return, no changes, no additional tweaks. Tesla's AI5 chip has reached that point. The chip is real and moving toward mass production. The manufacturing process has been entrusted to the two most advanced semiconductor facilities in the world. On top of that, Tesla is building its own chip manufacturing plant in Austin with a budget of $20 billion allocated for just 1 year of operations. But what truly surprised the market wasn't the chip's existence, it was its purpose. The AI5 isn't going into cars first, not into the robotaxi Tesla has been preparing. It's going directly into the Optimus Gen 3, the humanoid robot that Elon Musk calls the most valuable product in the company's history. And alongside that decision comes a bold claim. The goal is to produce 1 million Optimus robots per year, starting in 2027. Why robots before cars? To answer that question, you have to confront an uncomfortable truth about the current state of intelligent robotics. Most AI-based robots that exist today operate on a model that depends on external servers. The robot collects data through its sensors, sends all of it to a central server, the server processes it and sends back instructions, and only then does the robot act. That seems to work fine until the network connection drops, the server gets overloaded, or the Wi-Fi signal on a factory floor cuts out. At that point, the robot stops completely. In industrial settings, that's unacceptable. A stopped assembly line because a robot lost its connection costs enormous amounts of money every single hour. But there's a second problem, and it's even harder to solve: power consumption. To handle complex tasks in real time, humanoid robots need high-performance chips. The most powerful AI chips available today, like NVIDIA's H100, consume over 500 watts continuously and cost $30,000 each. A typical humanoid robot's battery holds just a few kilowatt-hours of capacity. If the chip alone is drawing 500 watts, the robot burns through its battery in just a few hours, and that's before accounting for motors, sensors, and all the other systems. In practice, the robot can't even make it through a single work shift. That's exactly why nobody has managed to build a truly autonomous humanoid robot at industrial scale. Not because of a lack of ideas, but because of the absence of a hardware solution. Tesla found that solution. Elon Musk described the AI5 in very specific numbers. Compared to the current generation AI4 used in Tesla vehicles, the new chip is 8 times more powerful in terms of compute, has 9 times more memory, and delivers 5 times higher data bandwidth. A single AI5 chip provides inference performance equivalent to NVIDIA's H100, but consumes only around 250 watts, half the power draw of the NVIDIA chip. 250 watts. That's the number that changes everything. At that power consumption level, the Optimus Gen 3 can run a full work shift on a factory floor without needing to constantly recharge. And since all the processing happens inside the robot's body, it doesn't need to send data anywhere. Every decision is made right on the spot, regardless of whether there's a Wi-Fi signal or not. Musk said it plainly. The AI-5 will give Optimus enough local intelligence to operate even without a network connection, similar to how Tesla's autopilot system works in cars without needing the internet. But what truly sets the AI-5 apart isn't just the numbers, it's the design philosophy behind it. Most AI chips on the market, including NVIDIA's chips, are built to serve many different customers with many different types of tasks. That flexibility comes at a cost. Those chips contain components that Tesla would never use. Tesla did the opposite. It stripped out everything unnecessary: general-purpose GPUs, standalone image processors, modules for functions that Tesla's neural networks never perform, and directed all of the chip's surface area and all of its power budget toward one single thing: running Tesla's neural networks as fast as possible. This is the same philosophy Apple applied when it moved from Intel chips to Apple Silicon. The result was MacBooks with twice the battery life and noticeably higher performance. Tesla followed that exact same path but applied it to robots. And the result is a chip that, in Musk's own words, costs a fraction of the price but delivers the performance of $30,000 hardware. Now we get to the part that many competitors simply cannot replicate, no matter how much money they have. Before Optimus sets foot in any factory, before it collects a single second of its own data, it has already inherited the entire visual knowledge base from more than 4 million Tesla vehicles driving on roads all over the world. That's 8.2 billion miles accumulated in real-world conditions: sunlight, rain, darkness, highways, narrow alleyways, unexpected objects appearing out of nowhere. All of it recorded, processed, and integrated into neural network training. That's an advantage you can't buy. Boston Dynamics has more than 30 years of history in robotics. Other companies in the industry are building their own datasets from scratch. Tesla starts with 8.2 billion miles, but the vehicle data is just the foundation. Optimus still has to learn how to use its hands, something cars never do. Tesla tackled this problem in a hands-on way. It sent engineers into factories to film workers as they performed their everyday tasks. Not to program the robot, just to observe and record people. How a hand grips a small part without dropping it. How the body automatically adjusts its balance when something heavy is being carried on one side. How the eyes scan the surroundings before entering a tight space. All the natural movements that people make without thinking were integrated into the training system. Optimus learns by watching humans, like a small child who learns to walk by watching adults without anyone explaining it to them in words. And Tesla took this concept even further. The possibility of having Optimus learn new tasks from instructional videos available online. It may be enough to show the robot an assembly tutorial video for it to understand the process and carry it out on its own. This is still in development, but the direction says a lot about the company's long-term ambitions. There's another layer to this story. Optimus doesn't only train in the real world. It trains in a world created by artificial intelligence itself. Tesla developed a system called the Neural World Simulator, an environment generated by neural networks trained on billions of hours of real video footage, capable of producing entirely new situations with fully realistic visuals, shifting light, objects moving at random, unexpected scenarios that no one could predict. In this simulated world, Optimus trains thousands of times, fails, learns from its mistakes, and tries again, 100 times faster than in reality. No risks, no damage, just learning. This leads to what Tesla calls the fleet flywheel, the flywheel effect of a robot fleet. The mechanism is straightforward. Every Optimus working on a factory floor continuously collects data. That data is sent to a central system, processed, and the knowledge extracted from it is integrated into updates to the shared AI model. Those updates are then pushed across the network to all robots, exactly the way Tesla pushes software updates to its cars. One robot encounters a difficult situation and figures out how to handle it. A few hours later, the entire robot fleet knows how to do the same thing. And as the number of robots grows, from a few hundred to a few thousand, all the way up to a million, the learning speed of the entire system grows exponentially. Not linearly, exponentially. For this flywheel to work, two things are needed simultaneously. A chip powerful enough for the robot to process data locally without issues, and a fleet large enough to generate a diverse and meaningful volume of data. Tesla is building both in parallel right now. And here's the key point. This advantage compounds over time. More robots generate more data. More data produces smarter AI models. Smarter models allow robots to do more things. More capable robots mean higher sales figures. The cycle continues, and the gap between Tesla and its competitors keeps growing. But it would be dishonest to only talk about the positives. The first truth that needs to be faced: the gap between claims and reality is still significant. On the Q4 2025 earnings call, Elon Musk himself acknowledged that the Optimus robots working in Tesla's factories are there primarily to collect data and train, and that they haven't yet created real economic value. He called it a research and development phase himself. When the media talks about 1 million robots in 2027, many people interpret that as 1 million robots operating at human-level efficiency. The reality is 1 million robots manufactured. Actual operational performance at that point is a completely different story. The second truth: the AI-5 isn't going into Optimus immediately. The chip completed development in April 2026. The first engineering samples are expected by the end of 2026. The robots currently working in Tesla's factories are still running on older hardware. Integrating the AI-5 into robots at large scale is a story that begins in 2027. And the third truth, perhaps the most important one: competitors aren't standing still. Boston Dynamics has decades of experience in robotics. Other companies in the industry are receiving investment from tech giants and have contracts with major retailers. And Chinese companies are manufacturing humanoid robots at a fraction of Optimus's target price. They don't have 8.2 billion miles of data. They don't have the fleet flywheel. But they do have cost advantages and speed to market, two things that the mass market values enormously. Tesla is playing the long game. The real question is, will the market have enough patience to wait? And will competitors manage to close the gap before the flywheel builds enough momentum to become unstoppable? The fleet flywheel is Tesla's real competitive advantage, not the chip, not the robot design. Chips can be copied, designs can be improved, but 8.2 billion miles of real-world data accumulated over years, combined with millions of robots learning in parallel 24 hours a day, that can't be built overnight. That's exactly why Tesla prioritized the AI-5 for Optimus over cars. The AI-4 is already good enough for vehicles. What the company needs right now is to get the autonomous robot learning cycle spinning as fast as possible. Every month of delay is another month the flywheel isn't running at full power. Once it builds enough speed, stopping it will be very difficult. 1 million robots. Artificial intelligence that learns on its own. A chip more powerful than $30,000 hardware. All of this is happening right now, not in a science fiction movie. If this content made you stop and think, share it with someone who hasn't heard about this topic yet. That's the best way to support this channel. Leave a comment if you see an angle that wasn't covered here. And if you're not subscribed yet, do it now. There's a lot more interesting content on the way.